Alright, in this video we're going to take a look at writing the equations for naturally occurring parabolic situations. These are things that when you use them or do them, they occur as parabolas, and a typical example is something like in the game Angry Birds. When you have a bird that flies, as you launch it towards the screen, it goes up and comes down as a parabola, and in the game Angry Birds that comes up all the time. So what I'd like to do is be able to write the equations for those. So writing equations for these comes from the most important thing that you need to remember for parabolic situations is the graphing form of a quadratic. So that's this. So y equals a times x minus h squared, and then plus k, and where the vertex is located at the point h comma k. That's the location of the vertex. The two keys to what we're going to be using in this lesson: one is the vertex, the point h and k, and number two, you need a working point, a point on the parabola that actually works, because that point on the parabola will be an x and a y, and therefore we've got an x and a y, h and a k. We can plug those in for y, x, h, and k and solve for a, and we can write the equation. So that's the process in order to do this. So let's take a look. Here's our first example. Let's say you're playing Angry Birds on your phone and you want to be able to write the equation for this is the parabola that showed up when you played it on your phone. So your first job is to do what's called set the origin. The origin is the meeting of the x and y axis. So I'm just going to say my origin is right here. If I do that, then I get to use the point 0, 0 as being a point on my screen. This is like where you launch the birds from. So that would be 0, 0. Then over in this direction, if you continue your x-axis, let's say you have a a phone screen that gets you over to 3 inches. So this is 3 inches, and then up here is 2 inches on your phone screen. And so then if I want to write the equation for this, it's easy because this is 0, 0, this is 3, 0, then this location of the vertex, the most important point of parabola, because it gives you the inflection point, it gives you the point where it has a line of symmetry through it, which would be shown here, the line of symmetry. So I'd go over 1.5 and up 2, so 1.5 comma 2 would be the location of the vertex. So then what I can do is plug all this into my equation. Your equation is right here. Well, guess what? All of these points are x's and y's, h's and k's in disguise. It's easiest probably to use this point as your x's and y's, because there's an x and there's a y and you can't mess up the order. Then here's your h and your k. So if you go ahead and plug these in then, so here's my y, there's my x, equals a parentheses, and then minus 1.5 for my h value, and then plus 2 for my k. If I multiply this out, 1.5 squared is 2.25, so 2.25 times the a value, and then plus 2. Subtract 2 on both sides, and negative 2 equals a times 2.25. Then divide both sides by 2.25. And this is where a calculator is going to come in handy, because now we're going to turn this into a fraction. So if I go negative 2 divided by 2.25, I get this really long decimal. Well, that's where we go math, enter, enter. To get the fraction, it's negative 8/9. So there's our multiplier, or our a value, excuse me, our stretch factor is negative 8/9. So there's my a. So now I can go back and write the whole equation. The equation would be y equals negative 8/9 x minus 1.5 squared, because that's the value of my vertex, my h and k, and then plus 2. So there's the equation for the parabola in the game Angry Birds if you're playing it on your phone. Now the next thing is, I'm going to show you this pool. I'm going to give you the dimensions. I'd like you to pause the video and figure out the equation for yourself. The pool is 30 feet wide, and it's 12 feet deep at its deepest point. You now should be able to pause the video and work it out and figure out what your answer is. Go ahead and do that. I'm going to work it out now real quick. Set the origin right here. So that makes this point 0, 0. It's on my parabola, and this would be 30, 0. My location, my vertex, would be 15, negative 12, because I went over 15 and down 12. And now what I need to do is go through and plug in all the numbers. So 0 equals a times 0 minus 15 squared minus 12, because my h and k, this is the 15 and this is the minus 12. And then 0 equals a times 225 minus 12. So I'm going to add 12 to both sides. Add 12, and I get 12 equals 225 times a divide by 225, and it's 12/225. Now if I put that in my calculator, and I go 12 divided by 225, I get this number, go math, enter, enter, it's 4 out of 75. So 4/75 is my A value, so my A is 4/75, and so my equation fully then would be y equals 4/75 x minus 15 squared minus 12. Hopefully now you're seeing that what it takes to really get this down is really looking for your vertex and your working point, because if you can plug in a vertex and a working point on your parabola and you get to set the origin, meaning you can put your 0, 0 wherever you want it, then you can use those values to plug it into this equation right here, and when you're done you end up with an equation that's in this form, and you've based it off of your vertex h and k and your working points, your x and y.